Climate change has prompted scientists to search for new ways to reduce greenhouse gases in all kinds of fields. Now, an Arizona inventor has discovered an alternative to the unlikely cause of fully 5% of the world's carbon dioxide emissions. Special correspondent Kathleen McCleary has the story, part of our Breakthrough series on invention and innovation.
I have here the last surviving bit of an experiment that went wrong.
13 years ago, David Stone was a PhD student studying environmental chemistry.
It was the corner lab right up here.
In a lab at the University of Arizona in Tucson, he hunted for a way to keep iron from rusting and hardening up.
It got hot, it started to steam, it was bubbling and spitting, and I thought, well, that didn't work. The next day when I came in and I found it and rescued it from the garbage, I realized this just didn't get hard. It got very hard, glassy hard. This one was cast by hand.
Stone, that's his real name, began to think his discarded rock just might be a substitute for a very common product, cement. It's been called the foundation of modern civilization. Portland cement, the generic name, is the glue that allows concrete to harden. And concrete is everywhere, in highways, bridges, sidewalks, buildings of all sizes, and much more. 4 billion tons of cement are manufactured each year worldwide, a half ton for every person on Earth. It has a huge carbon footprint.
How's it running?
Steve Regis is Senior Vice President at Cal Portland, one of the nation's top 10 cement producers.
This plant, if it's making about 1 million tons a year of cement, will emit roughly 800,000 tons a year of CO2, of greenhouse gases.
One reason is the extremely high heat, about 2,800 degrees Fahrenheit, needed to process the limestone used to make cement.
In making cement, we actually make new minerals, and that uses a lot of heat to cause that chemical reaction to occur. This plant here, when they're making 1 million tons a year, is burning on the neighborhood of 20 tons per hour of coal.
David Stone uses a very different formula.
This is the basic recipe, if you will.
One that doesn't require high heat and recycles materials from other industries.
The whole process is green.
A key ingredient is iron, something he gets from steel mills.
I discovered that there was this material called steel dust that is not recycled, so it typically goes straight to the landfills.
Silica is added to the mix, and that comes from ground-up glass. Finding that wasn't hard either. Stone connected with the community college at the Tono O'odham Nation, a Native American reservation the size of Connecticut in southern Arizona. There he met Richard Pablo, a recovering alcoholic looking to turn his life around. Pablo knew where to find plenty of used glass.
Cleaning the desert and picking up those bottles kind of gave me an energy, a positive outlook. And then I started thinking about that there's a power behind that, a spirit behind that, even behind that bottle.
Stone's material, called ferroc for the iron, has another environmental plus.
You can say we're walking on trapped CO2.
It's a kind of carbon sponge. Stone adds CO2, which makes it harden, for example, into concrete paving slabs like these.
We're stepping down on climate change. This is a carbon negative process that helps trap the greenhouse gas, carbon dioxide.
That caught the eye of the Environmental Protection Agency. Then EPA Administrator Lisa Jackson came to the reservation, and she too walked on ferroc.
This is the steel wire support structure.
And gave grants of more than $200,000 to build demonstration projects, which employed tribe members like Pablo. The prospect of jobs on the reservation has made Stone's work attractive, says Casey Thornbrew, project director for the Land Grant Office of Sustainability at the community college.
As projects come up, such as campus buildings, homes, businesses that want to use the material, that's where the jobs come in.
Stone won a prize for his invention while a student. The University of Arizona helped him secure a patent and later licensed the technology to him. And now he's formed a company called Iron Shell.
It's taken about 80 pounds of load now.
Experiments on ferroc's strength and durability are underway at Arizona State University in Phoenix.
can see here, it's really cracked inside.
Professor Narayana Nathalath, a civil engineer who develops sustainable materials, is testing Ferroc.
When you talk to anybody about concrete, the first thing that they'll ask you is what's the strength. We have found out in our work that this is about 5 times tougher than your conventional Portland cement concrete.
That strength might help protect a building from an earthquake, a tornado, or even a bomb, like the one that brought down the federal building in Oklahoma City in 1995.
What happened in Oklahoma City bombing was the explosion demolished all the columns of the building, and the building crushed because of the weight of it and the columns not being able to support them. But if I have a blast-resistant material for something made out of this material, what you will have is the columns will still become weaker, but it won't collapse just like that, and you will save loss of lives and loss of property.
At Cal Portland Cement, officials say their product has stood the test of time for more than 100 years. They've won Energy Star awards from the EPA for 11 years running for their energy-saving efforts. Among the achievements, using alternative fuels such as old tires and recouping some of the CO2 emissions.
You know the problem we had at Rita?
Steve Regis says his company is always on the lookout for new ways to make cement, but says Ferroc isn't practical for a large-scale operation.
Dave's idea, I think it has a good niche market for non-structural block, yard art, benches, but consider the scale of that compared to a 200-mile 6-lane freeway, 8 inches thick, or a runway.
Stone is well aware he's David to a very big Goliath, but he thinks there'll be a market for Ferroc eventually.
I'm doing my part as best I can to respond so that when the time comes and the world wants to build with new materials that are carbon neutral or carbon negative, I'll be able to step forward and say, yes, I have such a material.
A material he hopes will one day make a lasting impression.
Here it is.
I'm Kathleen McCleary for the PBS NewsHour in Tucson, Arizona.